Hey, Greg.
How you doing?
It's good to have you, Greg Laemmer.
Likewise. Likewise, Jerry.
How did that come to fruition? You being Greg Laemmer.
So I've been in sales for 25 or 30 years now, and prior to MIRATAK, I spent a little bit of time, short amount of time, with a different OEM engine manufacturer that shall be nameless. And had a boss that walked me around the office and introduced me to all the other sales guys and gals in the office that day. And he was proud hiring his new guy, Greg Laemmer. And he introduced me to everybody in the office as Greg Laemmer. And each person I shook hands with, I had to correct and say, "It's Greg Laemmer. Nice to meet you." And each time it went right over his head. And I used that story, and that all of my friends now from that time still call me Laemmer. And then I told the story to David Zentafer and a few other people at one of these meetings that we had a number of years ago, and told the story. And from then on, now everybody at MIRATAK refers to me as Laemmer.
David is our CEO at MIRATAK. We call him DZ, and so he never misses an opportunity to say, "Hey, Greg Laemmer."
Hey, Greg Laemmer. And then he reminds the HR folks that he does know how to pronounce my name.
After every time he says it.
Exactly, because he's afraid that he might get called out.
Well, thanks for being on here today. I know that you're in town for some meetings and making some time for us to come talk about power gen emissions and how it relates to us. So I know that you've been in this business. How long have you been in the emission side and noise pollution
side and noise? 17 years. I think this might be year 18, something like that. So long enough to know better.
What's been the biggest thing that you've seen that has just kind of blown your mind from the way that the market has progressed?
Yeah. So I go back to 2002 and 3 when the EPA tier requirements came down on engines, and that was a big time for all of us who were in the engine market and engine world. And when I came over to MIRATAK and started selling catalysts and other things, the tier discussion became more and more relevant to everybody. And then tier 4, which is what a lot of people will hear us talk about. We use it every day. It's part of our vernacular, but it does mean something. Tier 4 was an EPA designation and rule that requires all diesel engines to operate below certain emissions targets across a range. So you have CO and hydrocarbons and particulate matter and NOx all have to stay below a certain value. And when that happened, when the EPA sets a rule, engine manufacturers react to that. So, and at the time, the rule, and still does, require these emissions controls in a couple of different scenarios. One is when the engines are running prime, meaning they're running all the time to keep the lights on no matter what. The other time engines run is in emergency situations. And most of what we deal with on a daily basis are engines that are used as backup power.
Okay.
We do both at MIRATAK. We do everything, but backup power is the biggest part of what's happening in our market today, which is mostly focused on data centers and data center projects, because many data centers are using diesel engines as backup power. And also now you have a number of data centers and power companies working together to use natural gas as a prime power source, which is a big switch. Mm-hmm. So when the diesel tier 4 requirements came on at MIRATAK, the understanding was that the factories, the OEMs, would have to do this work and create a factory certified solution. And the problem with that was you need to have a big market for that if you're an OEM. If you're going to spend millions of dollars to develop a system, you need to have a reason to do it. You need to have a demand that's there. The demand was light, the demand was thin, and the applications where a diesel engine needed to run in a prime application were few and far between. So not all of the OEMs jumped right in to building a system that would be able to be used on all of their different engine sizes. And at the same time, at MIRATAK, we had meetings with David. Our small little sales team at the time, might have been 4 or 5 people, sat around a table and we wondered, okay, what are we going to sell now that EPA has required this? The engine manufacturers are going to build it themselves. Who are we going to sell SCRs to? We won't have any customers left. So we sat down and made plans of what are we going to do if we can't sell our main product. And over time, what happened is the market realized that because demand was inconsistent and niche-y and different, and that many of the regulations and requirements were actually a little different or even more stringent than Tier 4, the OEMs kind of decided maybe we'll leave that to the aftermarket to manage for us. So we did, and we continued to sell SCR systems and DPF systems onto diesel engines, and created what we now refer to as the compliant marketplace. So the other things that we say around MIRATAK all the time are compliant systems, Tier 4 compliant, which is very different than Tier 4 certified. Certified means that the engine OEM builds it and they control the system that today we build. And compliant means the aftermarket, like us, build a system that controls those contaminants the same way a certified system does, but with more flexibility and more capability. The biggest problem with Tier 4 certified for people in the data center market, hospitals, life safety, anything mission critical, is that the Tier 4 rule requires what's called an inducement strategy. So if the engine is running along using an aftertreatment system and something on the aftertreatment system breaks, like the urea DEF tank runs out or an injector fails on the aftertreatment system, what happens, just like what happens in your diesel truck over the road, your engine goes into a derate and you can't get full power. So imagine that if you're a data center and a little thing on your $1.5 million generator breaks, the whole thing shuts down because of the emissions. Not going to work, right? Not going to fly. So the compliant system, the big difference there is that there's no inducement strategy and no inducement requirement. And that opens the door to all of the manufacturers like us to support and supply to mission critical facilities, because nobody in the mission critical area can use a certified solution because of that problem. Because if you're in a life safety situation or a mission critical situation, you can't have the engine not producing power because the DEF ran out.
Right. Right.
You just got to keep on running.
Yeah, that's not good if a hospital is relying on some of those kinds of things and power goes down. And
maybe Jerome, if you were on the operating table.
Jerome.
Oh, sorry. I mean, Jerry. Anyway, so
yeah. Well, you talked about natural gas and diesel, and you know, we have been really focused on being kind of fuel agnostic a little bit. So what are some other types of fuel that you're seeing are
so fuel over the years has been interesting. So when people have tried to make diesel prettier, so over the years, we started out with biodiesel 10 or 12 years ago, and plants and things were growing out of people's diesel tanks. That didn't work very long. And because of the fossil fuel regulations and requirements and political push and things like that, other options came about, one of which is called hydro-treated vegetable oil. And it's, or HVO. HVO, baby. And so all of the manufacturers of engines have certified their engines to run on HVO. We've done the same thing, although, you know, there really isn't much difference between fuel or engine to engine or emissions with HVO. It's just a non-fossil fuel. So you can check that box as a data center or an operator that you're not operating on fossil fuel. So some of the large projects that we're working on today with some of our larger customers are using only HVO now.
Okay.
And on the gas side, on the other side of the world, you've got natural gas, you've got landfill gas, you've got, you know, coming on hydrogen and other fuels. We've even had dual fuel engine situations where you have pilot fuel using diesel and then they run on natural gas. The landfill gas ones are interesting because there's a lot of stuff in landfill gas, a lot of garbage, a lot of stuff coming through, and we have to manage that as well. So yeah, fuel agnostic is a good way to put it. We're engine agnostic as well. We treat the exhaust, not the color of the engine.
So like if we were to translate what we do to real world environments, we start even getting into like, what does it look like with data centers and translating it into everyday life of what does a Netflix binge look like?
Yeah. What is going on at the data center that I should care about from the environmental?
Exactly. Talk a little bit about that.
Yeah. So we talk about it in our little world at MIRATAK. We talk about it every day in a way that is focused on our product, focused on our customers or a particular project, and we use all the 3 and 4 letter terms, acronyms, the CO and NOx and O2 and PM and particulate and all these different things, and we say it every day like it's your kid's name,
right?
But in reality, with real world situations or real world comparisons, sometimes it's not simple to us even. And I was just talking with you about it before we started. At a data center, for example, or any large construction project where you have backup power systems, most have permit limits that limit any particular constituent of pollution. So nitrates of oxide, we call it NOx. CO, hydrocarbons. Hydrocarbons is the stuff that smells bad. You get behind a car and the exhaust is coming out. When you smell it, hydrocarbons.
Okay.
CO, or in some cases, you have formaldehyde reduction, gas engines, other things, or ammonia reduction if you're running, additional ammonia on a system. All of those things for us become everyday terms. But what do they mean?
What do they really mean?
So a typical data center needs to keep a particular constituent below 25 tons per year, if they can.
Okay.
And that becomes a challenge because a lot of these data centers are growing, as we all know, fast, and a lot of them are campus-based, so they continue to add on engines regularly. So they're continuing to expand their full base of missions. And their permits for those particular sites typically limit them to a value, and those values are determined whether it's by air modeling, by engineers who look at how the pollution floats around in the air and where is it going to go and where is it going to land and how much can go there. It's all Wizard of Oz stuff, even to us. But at the end of that, there's a limit. There's a number. And those data centers need to stay below that number because what they don't want is to have to turn their site into what's referred to as a Title V site, which is when you're above those numbers, then you have the federal folks coming in to manage that permit situation.
Whole new level of scrutiny.
Completely different. And in most cases, that's not the case.
Yeah.
But in some, it is.
Okay.
And we've been involved in both.
Yeah.
But the understanding, when we talk about tons per year, right? What is it? Tons per year of pollutant, right?
Yeah.
So
let's take NOx, for example.
NOx is the one that everybody talks about.
All right. So if the cap or the permit is 25 tons
per year
of NOx
and this is 25 tons per year from the site. So it might be 20 diesel engines, 50 diesel engines, 100 diesel engines.
Yeah. That permit doesn't go up with the number of engines that are out there. It's per site.
That's right. So
it's 25 tons of NOx.
25 tons of
Break
NOx.
that down into what is it? What's that mean?
Yeah. So a ton of NOx is exactly the way it sounds. It's a ton. And NOx is a nitrate of oxide. And you think of, when we think of pollution today, you look up in the air or you see it coming out of a smokestack. You see a plume. You see stuff.
Yeah.
A gray cloud or a black cloud or a white cloud. When you see a cloud like that, something's in there. And it's either harmless, which you would hope that something's been controlled, or it's a lot less harmless than it could be, that's our case. But if you see a plume coming, there is pollution in there. And NOx is typically a yellow haze. If you talk about pollution back in the 80s in LA, you'd fly in and there'd be a smog, yellow.
Yeah.
That's NOx. Right?
Okay.
So that's in addition to PM. Those are the two real big ones that the EPA focuses on.
And PM meaning
particulate matter, right? And in particular, diesel particulate matter, which comprises a lot of stuff. We can get into those details, but 25 tons. So a ton of NOx is what it sounds like. It is literally a ton by weight of material. So 25 tons is the same as 50,000 pounds of this stuff coming out of a pipe, right, blowing into the air. But it doesn't just stay in the air.
Yeah.
Right? Now, sometimes NOx does because it hazes and it holds. But a lot of this pollution, if you think about it, goes up into the air and then it doesn't just hang out there. Some of it could. A lot of it, particulate, will just come back to the ground. If you think about it, like even today, people are talking about the incredible harmful effects of leaded gas. And leaded gas in certain areas in a lot of places, because of the way they created leaded gas and the use of leaded gas is in the soil now, right? But it didn't start there. It came out of a pipe and flew out into the air and then it landed on the ground. So we're talking about literally tons of material that our systems reduce. So we take an SCR system to reduce NOx and we create through chemistry a process to remove that NOx up to, we'll call it 99% of that NOx can be removed depending on the efficiency required, depending on how dirty or clean the engine is. But we are literally, as a company, reducing the tons per year of that contaminant that flowed out into the atmosphere and eventually land or go into your lungs, not mine, yours.
Oh, mine. Yeah,
just yours.
Yeah,
but
because mine
what
are
happens
stronger
here.
than yours.
Yeah. So that's what we're talking about. We're literally talking about removing tons of material per year.
So if we take this permit of 25 tons of NOx and we're translating it into the space and like what it means in real
life. So I think I've
so
heard
it's 50,000 pounds. We talked about that. It's 50,000 pounds. And so in everyday terms, what does that look like?
So let's say your car. Let's think about your car. Okay. I think I'm kind of guessing here. I think your car might produce, 0.7 or maybe something like 7 grams of NOx.
0.7 of
per mile.
grams? Yeah.
0.7 grams of NOx per mile, let's say. Okay. In order to put this in perspective of a single data center needing to maintain a less than 25 tons per year value of NOx, that value, I think, is something like driving your car or going to the moon and back 60 times, something like that.
That is insane.
It is a huge amount of reference material to process because I think about it as a little campus. It's compared. It's not a very big area there, but all of the horsepower that's there to back up our internet or to push our AI, if it had to run on diesel, which it might have to, and depending on the scenario, in 1 year's time, that's the limit. But that's a big limit, right? So at MIRATAK, we take that 25 tons and we put our system on, and we might reduce that overall number by 90 to 95%. So the more MIRATAK systems go on engines, the more engines can be installed at a site. Does that make sense?
Yeah. And that comparison of trips to the moon, over 60 trips to the moon, or 1,200
driving your car around the world 1,200 times or whatever, right?
That's one site.
That's just one site, one data center. And today, I think the last count I had of current data centers either in permit or under construction is something like 3,000 in North America right now.
Wow.
And maybe 4,500 to 5,000 if you include Europe.
So doing the math on that is an insane amount.
It's a lot more math than you're able to do.
And it might power us to get to Mars. Everybody's trying to get us to Mars.
That'd be a way to do it, right?
Maybe we just trap NOx.
There you go.
Like reduce it.
How to turn it into fuel, and the next thing you know.
Well, another analogy that you and I had talked about prior to hitting the red button on record is a balloon analogy.
Oh yeah. So I think it was 860, close to 1 million balloons would full of NOx.
Yeah.
Would equal that amount sitting over the top of the data center. So if you imagine a data center sitting out in the middle of a cornfield with 1 million balloons sitting over the top of it, that is the capability that data center has to emit. That's the maximum they're allowed to emit of pollution. And in my mind, that seems like a lot.
Well, that's like a football stadium packed with balloons.
Full of balloons.
And times it by 10.
Times 10. Yeah. It's an immense number. The balloons would take up far more area than the building by a long shot. So it is hard to put into perspective, but the reality for the average person to know, and the important thing to understand is that folks like us and our competitors, because they're good people too, we like them, are reducing these pollutants for these data centers and keeping them in compliance with not only local and regional jurisdictions, but the EPA. And we're keeping the air clean. It does make a difference. And the reality of diesel engines today is we can make the diesel engine cleaner in many cases, depending on where it goes. Virginia is a perfect example. We can make those diesel engines cleaner than the utility power being used to power the data center itself. So our technology is so good that when you couple that with how expensive and how dirty it is to get the power made that the utility is providing, that we can show with data that running a diesel engine with a MIRATAK system is cleaner than your utility power. So the diesel is not dead.
Mm-hmm.
The diesel is an important part of what we're talking about, but it sounds dirty. The big, bad, dirty diesel engine.
Yeah.
Everybody wants to get rid of it and everybody wants to push it to the side. But the reality today is these data centers are running them on hydro-treated vegetable oil.
Mm-hmm.
They're not pulling fossil fuel out of the ground to run the data center diesel. And we're cleaning that diesel up so well that they can install a lot more of those engines out there and not get close to that 25 tons per year threshold. So that's what we are doing. We're trying to clean that up and turn that into a harmless emission rather than letting them just run.
Stuart was on a podcast not too long ago.
Big guy, Stuart.
A big dude.
Mm-hmm.
Big dude.
Yeah.
He had said that diesels somewhat get a bad rap. And you're saying diesel's not dead.
It's not.
Yeah.
No, it's not. And the reality is that virtually every data center operator out there is using them. They may not want everyone to know because it might go against, their green initiatives and other things, but it's the best backup solution for a data center. It's the fastest best uptime. It's the proven leader in the clubhouse for backup power. Natural gas is coming up behind there, but what's happening with natural gas is that's becoming a behind the meter piece. So what some of these data center folks are doing is they're using engines, large natural gas engine plants, to be completely grid disconnected and running 100% on gas fuel, which is a huge change and a shift in the way these plants or these data centers have operated in the past. And like I think Stuart was talking about, it's a power problem.
Yeah. Yeah.
We're in it. We have a huge power problem.
Yeah.
And everybody knows
availability is
power availability is the issue.
Okay. So if we reduce up to 99% of NOx, for the people that don't understand this, what do we do with it?
Where does it go?
Yeah. Where's it go? Like, do we
put it in a garbage can?
Yeah. Or do we
recycle it,
capture it all and then shoot it somewhere?
Right.
Which would be kind of fun.
Yeah. Might be. Good idea.
Where's it go?
Yeah. So, when we talk about reducing emissions, we are doing just that. We are creating a chemical reaction that reduces the NOx. So in the case of NOx, we'll just use that because it's kind of complicated and kind of interesting, but relatable. Today, the big over-the-road diesel trucks that are driving up and down the road today, they have a system installed where they have to use what you might see out on the road at the filling station as DEF or AdBlue. We call it urea, but it's all the same stuff. Our system injects AdBlue or urea into the exhaust stream at a temperature and converts that to ammonia. Mm-hmm. And that ammonia then goes across our catalyst bed and eliminates and converts the harmful NOx into harmless emissions. So CO2, water, coming out the other side. There's still going to be, if we reduce 98, 99%, there'll still be some trace emissions there, but 99% less than there was if there was nothing on the engine, right? So 99% is an extreme example. Typically, it's in the 90s somewhere. So as an average reduction, Tier 4 is about a 94% reduction from current day raw levels. So
but I'm in marketing and we want to say 99%. No kidding. No, our engineering will go nuts.
That's right. But we convert it through a chemical process. So we don't have to store it when it's done. It doesn't do anything. It's changed chemically. So it's the magic of chemistry that reduces it. So we don't have to put it in a garbage can and put it in Jerry's backyard. We eliminate it and it doesn't exist.
It literally changing from harmful to harmless chemically. And, I'm everybody knows I'm a chemist.
Yes.
And I majored in that. So for me to explain that, you did it at a person that could really understand this.
Kept it at your level.
At a Laemmer's terms.
Jimmy. Yeah, Jerry.
Our producer, Jordan, has a lot of really good questions just sitting here because he's not in this industry.
Sure.
And his son has a landscape business and has a diesel truck. So
likes to roll coal.
Roll coal, baby. So let's talk about that for a second.
So rolling coal. Yeah. So that's an automotive term, obviously. It comes from the truck world. And I think there's a whole cultural group and then a vernacular around the diesel truck and the rolling coal. I've seen all the videos. The algorithm has found me because, somebody rolling their big diesel truck past a Tesla or past something and blowing all kinds of black smoke on it. What is that, right? So we've been talking about diesel emissions. Particulate matter, okay, is what that is. So that black smoke is particulate. It's called diesel particulate. And the DPF, the diesel particulate filter, is what removes that or reduces that. And when someone rolls coal, what they're doing is regenerating their DPF. So in our world, we sell DPFs that are bigger than the truck that we're talking about, right? So our DPFs are the size of a half of a truck trailer.
Yeah.
But a little DPF like that, just like ours, will trap. Some used to call it a particulate trap or a soot filter. The way the DPF is made, the material, the particulate that we talk about, the actual pollution gets trapped in the cells of the filter and the heat burns them off.
Wow.
So when the heat burns them off, you're rolling coal.
Yeah.
Right?
Yeah.
We call it regeneration.
Okay.
Right? We don't call it rolling coal because it doesn't look good in the submittal.
Yeah. Yeah. Regeneration sounds way better.
Yeah. And you can almost pronounce it if you work on it.
But let's talk a little bit more about the social impact of, we talk, one of the things that we're really trying to talk about is the human health effects.
Yeah.
And, we can go into and dive deep into that data, but to kind of get people to understand conceptually about what we're talking about in real world, let's go back to kind of like the social media side of stuff or Netflix. It all starts with the puff of exhaust, and I don't know what your habit is like on Netflix binges. I know you watch a lot of,
that's heavy, a lot of binge watching of Lord of the Rings.
Well, I was going to say more of like those dating shows that you
might be,
probably more so, and cooking,
Bachelor in Paradise.
Yeah.
Right.
But like if you were to kind of help us translate Instagram feeds or TikToks or what all kind of power that consumes, help us understand that a little bit.
Yeah, it's hard to put those into specific similar numbers to the going to the moon, but if you look at your habits, and it may not be as much your TikTok habit coming forward as your habit to use the Chat GPT box, right? Or the Gemini box or the Grok box.
Yeah.
Because what we're seeing is the movement toward that. And part of that change, when you go from just watching Netflix to utilizing Grok, utilizing Chat GPT, asking a lot of crazy questions or personal questions, or I know the kind of questions you ask ChatGPT, right? But when you do that, you notice if you ask a very complicated question, it takes a little longer for the information to come back. And what's happening back there
I've noticed
is action, right? You ask a lot of complicated questions, Grok gets a little, slows it down a little bit.
Yeah.
But what it's doing is it's thinking. And when it's thinking, it's using a lot more electricity to think. And when you use a lot more electricity to think, you need more electricity to back up that thinking if the power goes out.
Yeah,
So,
I think we talk like AI consumes 10 times the power as a regular Google search.
exactly. So if you're using ChatGPT and you are not using your Google search anymore, you could say you're part of the problem, right? You're using more power than you need to. But it's inevitable that that's going to happen. But what you can look at is you can look at the fact that your scrolling activity or your ChatGPT activity is adding to the demand of power that is being talked about globally now. And data centers in particular are kind of in focus there because people are saying that data centers are sucking a lot of their power and the grid's going to be constrained and we're going to have issues with it. And sometimes, people will pose questions, would you be willing to give up your TikTok scrolling for 2 days if it meant that, 5 tons of particulate wouldn't fall on your neighborhood?
How do you think people would receive that?
I don't think they would care one bit. I think they would go right to scrolling just like we all would.
Yeah.
And go right back to it. But it is an interesting thing to think about.
So let's kind of wrap up with a final question here. Final thoughts with Greg Laemmer. Where do you see, we talk, part of the reason why we do this podcast is for, kind of thinking what the future looks like for our customers, not just our customers, but for the world in general. So when it's specific to data centers and when it's specific, I asked Stuart the same thing, to the emission side of things, what do you feel like the future holds for our industry? That's a great question, by the way.
I give you some credit there,
thanks,
Jerry.
I did not ChatGPT that question either.
So I think the future, or, not only for us, but what we're watching happen with the build out is what they're calling of data centers and the what we see the curve of growth that's happening, because we've seen a lot of growth as a company and the market's seeing a lot of growth. Everybody who's doing this is saying the same thing. We all talk about it when we're together, boy, aren't things great. But as a future, I think what happens is the more horsepower that's being built and put out on sites compresses the requirements more and more, which increases the need for more emissions requirements. Because if you put more horsepower, more diesel engines out there, you have to control what's coming out, like we talked about. So our future, based on how the engine market is going and the fact that more engines are being produced and every manufacturer we're aware of is building more capacity to build more, there's nowhere to go but up, and there's no possibility of us doing anything other than adding more systems to more diesel engines to reduce more pollutants. It's math. And the reality of the data center and AI build out that's where we're going.
It's almost the sky's the limit. And as tried as that kind of sounds in terms of what we do and all that, it really is true. The sky's kind of the limit with this growth that is continuously happening for the next few years.
For sure.
Thanks for being on the show today, man. I really appreciate you coming in and helping us kind of tangibly put our minds around these emissions and all that, because this is something that people don't really talk about. We focus a lot on, it's this product, and we don't, what's it mean for real world?
Right.
So I appreciate you kind of articulating that.
No problem. And your name was Jared.
Gerald. Gerald.
Okay.
Yeah.
I'll get it next time.
Thanks, Gene.
You got it.
I'm here to tell you that MIRATAK is expanding. We're constantly growing. So if you'd like to be a part of MIRATAK, we'd love to have you. You can go to our website, MIRATAKcorp.com, to our career section and find the open roles there. So feel free to take a look, be a part of this family and what we're doing for the earth.